definitely eyes on the prize. We're trying to find the likelihood that an event will occur. That is our objective for today's lesson. And you see that we have some, vocabulary sitting there. The first word we have is the word probability. And our definition for the word probability just says it's a number from 0 to 1. So if somebody says there's a 110% chance that it's going to rain tomorrow, they're kind of full of a little bit of baloney. It's a number from 0 to 1 that indicates the likelihood an event will occur. You could write probabilities as fractions or as percents. The first type of probability that we're going to take care of today in class is called theoretical probability. Theoretical probability, our definition takes up a pretty big chunk of space here, but it works a little something like this. When all outcomes are equally likely, it's not a two-sided coin, it's not a weighted set of dice, it's not, marbles with like bends in them. When all outcomes are equally likely, the theoretical probability that an event, call it event A, will occur is this phrase up here. We have the number of outcomes in event A. We often call that our favorable outcomes over our total number of outcomes. So I often write this as if we want the probability of event A happening, I often write it as our favorable outcomes over our total number of outcomes. Uh-oh. For you. Do you know what this circle thing is called? Do you remember what those are called? Begins with a V. Rhymes with hen. Molly? Venn diagram. Yeah, very good. So what we see here is just a nice little map or diagram of how you could represent probabilities. And what we see here in this little bubble is our favorable outcomes. But when you go to calculate probability, it's not just 3. It's going to be a number between 0 and 1. So if I wanted to write the probability for what's demonstrated or displayed here in our Venn diagram, we have our favorable outcomes, which is, so if we wanted to write the probability of event A happening based on our Venn diagram, we have 1, 2, 3 favorable outcomes over the total number of outcomes. So we would have to count all the little dots in that Venn diagram right there. So I see I already have 3 checked off, 4, 5, 6, 7. So it would be the total number of outcomes on the bottom. By the way, just, your textbook here clarifies a little bit. When we talk about the theoretical probability of an event, that is just simply called the probability of the event. So it's not going to say find the theoretical probability. It's just going to say find the probability that A happens. They drop that word theoretical because that's the kind of probability that you folks actually are going to calculate probably most often. It has a little bit of a counterpart, experimental probability. We're going to talk about that today as well. So theoretical probability is just sort of like, in theory, how many marbles would I get out of the bag? Whereas experimental probability has you doing an experiment to calculate that probability, actually pulling the marbles out of the bag so many times. We'll talk more about the difference between those in just a minute. Okay. So just a simple little example here. We have you're asked to roll a standard 6-sided die. And I want to see what you kind of know about probability. I want you to think about the probability of rolling a 5. Remember our formula, it's the number of favorable outcomes over your total number of outcomes. So how many 5s are there versus how many sides of the die are there? And then for part B, I want you to find the probability of rolling an even number. Okay? I'm going to go ahead and let you do that for a second, and we'll talk about it. All right. So Kyle, what'd you get for part A? Yes, very good. 1/6 is your answer there. And Will Hoffmeyer, what'd you get for part B? Yep, how'd you get it? Yeah, very good point. I'm glad you made that leap. I didn't explicitly say it, but you always have to reduce your fractions. So in this case, you had to reduce out that factor of 3. 3 over 6. You can't leave that as an answer. Got to put it down as a half. Questions about that? Okay, now you're going to see that I don't do example 2. It's probability with permutations and combinations. It kind of muddies the water a little bit too soon. I'm going to save example 2 for tomorrow. I just want to get basic probabilities down today. Make sure you're good with that. And then tomorrow I'll teach you how to do probabilities with permutations and combinations in them. And then I'm also going to talk to you tomorrow a little bit about geometric probabilities. You might recall on yesterday's bookwork we went over some area formulas. Well, that's for tomorrow's lesson. So you're going to have some access to some area formulas sort of in your brain. So I am skipping example 2. We're going to do it tomorrow. Now I need to talk to you about odds. It's a word that sneaks up on my students on tests. It's probably one of the causes that I see for errors most frequently on the Chapter 10 test. There are problems that say, find the odds of. And immediately when students think of odds, appropriately so to a certain extent, they think of probability. The two things are linked, but they are not identical. Notice our two different formulas that we have here. You have the odds in favor of an event. The formula for that is, the top number is going to be the same. It's your number of favorable outcomes still on the top. So if you want the odds in favor of event A happening, your favorable outcomes still go on the top. But look at the bottom. It's not out of the total anymore. It's out of the number of outcomes not in A. In other words, the leftovers. So please understand that the difference between odds and probabilities is in the denominator. In probability, the denominator is your total number of outcomes. But with odds, it's just the leftovers that weren't in your favorable set. We can also do odds against an event happening. And this is just basically the reciprocal of odds in favor. So you'll see that the numerator this time around, if it says odds against, we want the unfavorable outcomes over your number of outcomes in A. In other words, your favorable outcomes. So to put this maybe in a less wordy fashion, it goes like this. Odds in favor of an event go favorable over not favorable. Notice it's not over your total. That's what I'm trying to draw your attention to. And this guy here is not favorable over favorable. And just a little switch up in the notation. Draw your attention to that just briefly. Also, sometimes you'll see odds written as a plain old fraction, but you might see them as a colon. We just had all those, prop bets for the Super Bowl. They give you odds. Most commonly, they're written like A to B. So you'll see both. Questions about that? Alrighty, so now we're going to do some odds. And we'll read this problem together. It says, a marble is drawn from a bag containing 6 red, 12 yellow, and 9 black marbles. In part A, we're supposed to find the odds in favor of drawing a red marble. And in part B, we're supposed to find the odds against drawing a black. So in part A, I'm supposed to find the odds in favorable of drawing a red. And I always set up a verbal formula for myself. What this means, if I want to find the odds in favor of drawing a red marble, I'm going to go ahead and find the number of red marbles over the number of marbles that are not red. So what I see is that I have, from the problem here, I have 6 red marbles. Should have done this in red pen, huh? I have 6 red marbles, and then I have 12 and 9 yellow and black marbles. Those are my unfavorable ones, the ones that aren't red. So we're looking at 21. You wouldn't leave it like that, however, you can't leave 6 over 21 as an answer. We do have to reduce it. 6 to 21, reduce out the common factor of 3. The odds are 2 to 7 in favor of drawing a red. Are there questions about part A? Now what I want you to do, I want you to try part B. Do the odds against drawing a black. Keen, what'd you get? It is 2 to 1. How'd you get that? Okay. Because 12 and 6, those are the ones that weren't black. So that's 18. And then you had 9 black marbles. Reduce it up. Keep in mind you could write it like this. 2 to 1 are your odds. Okay, questions about that? All right, something you might want to kind of pay attention to. At the beginning of the lesson, we defined probability as a number between 0 and 1. But if you look at your answer to part B there, is 2 between 0 and 1? No. So, you know, you kind of want to keep an eye out for that. If it says odds, it's okay to get a number that's kind of off like that. Probability, if you get a number that's 2, reduces down to 2, you did something incorrectly. You made a miscalculation. So that's a kind of a way you could check yourself as well. Alrighty. Last type of probability we have to talk about today is called experimental probability. And this is probability that is calculated by performing an experiment or a simulation. There's a formula for it. I'll give you that in just a second here. Again, it's the probability calculated by performing an experiment or a simulation. And when an experiment is performed that consists of a certain number of trials, the experimental probability of event A happening is this. We still use P of A, this function notation that we've grown oh so fond of over the course of the year. We read this, though, as the probability of A happening. And again, it's a probability. So what we have for our formula is the number of trials trials where A occurs over our total number of trials. So again, we get this idea for probability. We get this idea for probability of, you know, we have favorable over total, which is different than odds. How do you know you're dealing with experimental probability? Well, you're going to be looking at data of some sort. In other words, you might be looking at something like this, a bar graph, a pie chart, which is a nice segue into what we're going to talk about in Chapter 11. A lot about bar graphs is what comes at you in Chapter 11. This one is a list of exam grades. And exam grades of students in a history class are shown in this particular bar graph. We're supposed to find the probability that a randomly chosen student in this history class received a C or better. Received a C or better. So what we have to do is, you know, I always write some sort of verbal model. What I'm trying to calculate here is the probability that a student got a C or better. Now, to break this probability down a little bit, what I've come to understand is that students who get a C or better are going to be the students that get a C, a B, or an A. So what I'm going to go ahead and do is I'm going to think about my favorable outcomes being students who earned an A, B, or C. And then my total number of trials in this case represents the total number of students who took the test. And like I said, it's called experimental probability because you're looking at some sort of collected data, an experiment that was done. In this case, it's kind of not an experiment necessarily, it's some tests were given. So in this case, I can figure out the students who earned an A, a B, or a C pretty simply. They even tallied up the columns for you. So nice. Basically, I can see that there were 8 students who earned a C, 12 students who earned a B, and then 7 students who earned an A. So I just add up those numbers to figure out the total number of students who fall into my favorable outcomes. In other words, they earned a C or better. And then you can add that now. 8 and 12 is 20, plus 7 more is 27. And then to figure out my total number of students, I have to take my 27, and then I have to add on 4 to get the total number of students. So I have, 27 and 4 more takes me to 31. So 27 out of 31, and that doesn't reduce. 9, 3, doesn't go into 31. So 27 out of 31 is the experimental probability that a student would receive a C or better. I noticed that the 27 is pretty close to 31, so we could say that that's likely. Students are likely to earn a C or better, so it's a pretty good test. Questions about that? Okay, there are a couple of independent practice problems that you're capable of taking care of. For instance, I would like you to go ahead and just start on number 1, and we'll have you do number 3 to sort of summarize what we just did in the first part of the lesson today. So I want you to try those. We'll go to our sticks of destiny here. Number 1. We have, using a standard deck of 52 playing cards, we're supposed to find the probability of drawing a red queen. Nathan, what'd you get? It's 2 out of 52, and then you reduce it up, right? So you get 1 out of 26. All right. Number 3 goes to Jackie. Yeah, 3 over 13, or you could do 3 colon 13. There are 6 yellow marbles, which represents our favorable outcomes, and then our unfavorable outcomes is 26. Careful, that bottom number should not be 32 because it says odds. So keep an eye out for that, especially on your assignment for tonight. Okay, any questions about our lesson for today? How much time do I have left? Not enough time to do. Okay. Have people run to their lockers to get their books. We'll do our last type of probability, just simple probability. We talked about theoretical. We talked about experimental. And now, last thing you're going to have to calculate, geometric probability. Now, theoretical probability is just basic, the probability of getting marbles or the probability of drawing a red card or what have you. Basic theoretical probability, we even dropped the word theoretical. It's called the probability that something happens. Experimental probability, you're dealing with that type of probability if you're looking at a chart or a bar graph or just a list of data that somebody has accumulated. Okay, and then lastly, we have geometric probability. You will know that you're computing this type of probability when there are shapes in the picture. So in example 4, I know this is listed as independent practice, but I usually have to kind of go through this a little bit like it's an example. You throw a dart at the square dartboard. Your dart is equally likely to hit any point inside the board, unless you're me. I never hit the board. It usually bounces off, lands on the floor. It's a big mess. We're asked, are you more likely to get 10 points or 0 points? Now with geometric probability, it's still the same. It's the number of favorable outcomes over our total possible outcomes. But in this case, it's not outcomes, it's area. So what we're looking about is, or looking at rather, is just the favorable area over the total area. Now to set up my formula for this, I need to know what shape represents the favorable area in this particular diagram. Can anybody describe it to me in words, what they see when they look at the diagram and think about the favorable area? By the way, we have two probabilities to calculate. Favorable area for the 10-point region and the favorable area for the 0-point region. Maybe we'll start with the 10-point region. The probability of getting 10 points. What's that going to look like? What does that shape look like? Well, what kind of circle? Orange, yellow, green, blue, what? Yeah, in this case, it's the yellow circle, the innermost circle, because you have a gray, black and white version. So in this case, I need to calculate the area of the yellow circle. In other words, the area of this innermost circle right there. Can anybody tell me what shape represents the total area on this diagram? Good, Patience. It is a square. Very good. And you did have to do some area formulas on your assignment from Monday night. You did have to find the area of the circle. I think it was on number 51. What's the formula for the area of a circle again? Nicholas. It is pi r squared. Very good. So in this case, I need to figure out the radius of that little yellow circle there. You see it? Good, Patience. Yeah, the radius is 3. Very good. So we're going to do pi times 3 squared, because the radius of this little yellow circle in there is 3. So we have pi times 3 squared over the area of the square itself. The area of the square itself, I see that the base is 18 inches, and we know in a square, all your sides are congruent. So this is going to be basically 18 squared. 18 by 18. And remember that you can write your probability as a fraction or as a percent. And when we throw pi into the mix, you know that there are decimals involved. So why don't you go ahead and take a second, throw this in your calculator. You're going to press pi times 9, enter, and then you're going to do 18 squared. You're going to divide those two numbers. So what is the probability, round to the nearest hundredth, what is the probability that we actually hit the 10-point region? Dirk, did you get it? Yeah, so if we were rounding to the nearest percent, let's say, what would it be about? Be about 9%, right? So 0.09. 9%. Now, a little bit trickier, we have to find the probability that we get 0 points. Do this in a different color. It's black, right? So we'll do probability that we get no points. Can anybody describe for me the region that earns us no points? Molly? Yes. In general, we're looking for the area of the black region, right? And this is going to be over the area of the square again. But to appropriately describe, as Molly said, the area of the black region, if you want to appropriately describe that, you have to basically punch out the circles. It's like you take out one of those hole punchers, and or cookie cutters or whatever, and you're taking out that area of the circle. So you're basically going to have to do the area of the square minus the area of the circle, the big circle. We'll put large circle. The biggest circle there is the blue one. And then this is, again, going to be over the area of the square. Now, some of you are probably like, oh, can't you cancel those areas of the squares out? No, you can't cancel around a plus or minus. You actually have to work this out. So the area of a square we did already find. That was our 18 squared, right? 18 squared, we have 324 in two different spots. Now, we have to think a little bit more about this area of the large circle, because that's what I need to figure out there. And as I look, the area of the big circle has this as my radius, that piece right there. And if each of these little increments is 3 inches, 3 plus 3 plus 3, the radius of the big circle is actually 9 inches. You could also look at the base of your square. That radius is going to be half of that, half of the side of the square. So half of 18 also gives you 9 inches. So to get the area of the circle, the big circle, we're going to do pi times our radius squared. And then we can throw that into our calculator. So we have 81 pi. And we're supposed to subtract that from 324. And divide it by 324. I got about 0.214. So I got about 21%. I'm not done with the problem because I have not answered the question. The question asks us, are you more likely to get 10 points or 0 points? So you're going to compare your 9% to your 21%. What are you more likely to get? Oh, go ahead, Patience. Yeah, 0 points. Yeah, so you just kind of write that as a sentence to wrap up the problem. You do have to ultimately answer the question. Okay. Does anybody have any questions about how we did this geometric probability problem? Okay, so again, your assignment for tonight is on page 702. I don't know if you noticed it or not, but we did just do Wednesday. We are a day behind on the itinerary. We did just do Wednesday because of the snow day. So tomorrow, which is Friday, we're going to do Thursday. So if you're going to be out, you can look to that for a little bit more direction.